Welcome back to another episode of Data Dynamics. Today we're diving into a topic that often sparks lively discussions among developers and data architects: schemas in document databases. We'll break down the differences between schema on read and schema on write, explore their implications, and see how they influence data handling across various applications. So grab your headphones and let's jump right in. To start, let's clarify what we mean by schemas. In traditional relational databases, data is organized according to a predefined schema. This schema is strictly enforced by the database, ensuring that all data conforms to it before it's written. This approach is known as schema on write. Think of it like a party with a guest list. You have to meet certain criteria to get in. On the other hand, document databases operate under a different philosophy. They're often labeled as schemaless, which can be a bit misleading. While you can add arbitrary keys and values to your documents without adhering to a strict schema, there's usually an implicit structure that developers assume when accessing the data. This is where schema on read comes into play. With this approach, the structure of the data is interpreted at the time of access, allowing for greater flexibility but also introducing some uncertainty regarding the fields a document might contain. Let's say you're working with a document database and decide to change how you store usernames. Instead of keeping a single field for the full name, you want to split it into first and last names. In a document database, you can easily start writing new documents with this new structure. Your application code can manage older documents without any issues. For instance, if the first name field is missing, you can extract it from the full name when you read the data. This kind of flexibility is a significant advantage of schema on read. Now, if you were using a traditional relational database, you'd face a more complex process. You would need to perform a migration, which involves altering the table structure and updating existing records. While many relational databases can handle these changes relatively quickly, some, like MySQL, can take a considerable amount of time, especially with large tables. This reputation for slow schema changes has led many to explore the more agile approach offered by document databases. Speaking of advantages, schema on read really shines when dealing with heterogeneous data, where not all records share the same structure. If your application needs to accommodate various object types, or if external systems dictate the data structure, a rigid schema can become a hindrance. In these scenarios, the flexibility of document databases allows for a more natural data model. However, when you expect all records to have a similar structure, having a schema can be quite beneficial. It serves as documentation and a way to enforce consistency across your data, which is crucial for maintaining data integrity. Let's also touch on storage and performance. Document databases often organize data to optimize for locality, meaning related data is stored together, which can speed up access times. If you frequently need to retrieve entire documents, this can be a significant advantage. But there's a catch. When you update a document, the entire document usually needs to be rewritten. This can lead to inefficiencies, especially if the document is large. So, it's often recommended to keep documents small and avoid updates that increase their size. Interestingly, the principle of data locality isn't exclusive to document databases. Other systems like Google's Spanner and Oracle's multi-table index cluster tables also leverage these principles within relational models. This highlights that while the document model offers unique advantages, the underlying principles of efficient data access are shared across various database systems. Now let's shift gears and talk about XML support in relational databases. Many relational systems have incorporated XML functionality since the mid-2000s, allowing for local modifications and indexing within XML documents. This capability blurs the lines between traditional relational databases and document-oriented ones, as they can effectively handle document-like structures. And speaking of document-like data, we can't overlook JSON. With the rise of web APIs, JSON has gained immense popularity, and many relational databases now support it. This trend suggests that the boundaries between relational and document databases are becoming less distinct, giving developers more options based on their specific needs. As we navigate these different models, it's essential to consider the implications of query languages. SQL, for instance, is a declarative query language, which focuses on what data to retrieve rather than how to retrieve it. This allows the database to optimize query execution without requiring changes to the queries themselves. In contrast, imperative programming languages require step-by-step instructions, which can limit optimization opportunities and complicate parallel execution. To illustrate this, imagine you want to retrieve sharks from a list of animals. In an imperative style, you'd write a loop to check each animal's family. But in SQL, you'd simply declare your intent. Select star from animals where family equals sharks. This declarative approach is not only more concise, but also allows the database to handle optimizations behind the scenes. Finally, let's consider the broader implications of these data models. The coexistence of document and relational databases enables developers to leverage the strengths of both. By adopting a hybrid approach, applications can benefit from the flexibility of document databases while still performing complex relational queries when necessary. This adaptability is crucial in today's fast-paced data landscape. In summary, the debate over schemas in document databases is nuanced. Schema on read offers flexibility and agility, especially in environments with heterogeneous data, while schema on write provides structure and consistency for more uniform datasets. Understanding these concepts is vital for making informed decisions about data architecture. As we continue to explore the evolving landscape of data management, it's clear that both document and relational models have their place, and the best solutions often emerge from combining their strengths. Thanks for tuning in to Data Dynamics. Until next time, keep questioning and exploring the world of data.